Good morning students. Today we will discuss about polarity of the bonds and dipole moment. Topic is polarity of the bonds and dipole moment. So polarity, what is polarity? What is dipole moment? So here we know that one covalent bond is of two types. Covalent bond is of two types. Covalent bond is two types. First one is non-polar covalent bond. Non-polar covalent bond. And second one is polar covalent bond. Polar covalent bond. So non-polar covalent bond means if the covalent bond exists in between same type of atoms, HH, Cl, Cl, Br, Br, oxygen, oxygen, nitrogen, nitrogen. So these all are homogeneous atoms. They are similar atoms. If the covalent bond is formed between similar atoms, then that covalent bond is called as non-polar covalent bond. So this is similar atoms. Similar atoms having same electronegativity. So having same electronegativity. So if they have same electronegativity, the bonded pair is equally distributed in between two atoms. Equally distributed between two atoms. So therefore there is no polarity. There is no polarity between atoms. So but in case of polar covalent bond, if the covalent bond is formed between dissimilar atoms. Dissimilar atoms means they having different electronegativity. If they having different electronegativity, what happened? The bond pair is slightly attracted by one of the atom. Slightly attracted by one of the atom. I will take one example here. HCl. The electronegativity of chlorine is more than hydrogen. Therefore, this bond is slightly attracted by chlorine. So, this bond pair is slightly attracted by chlorine. We get negative charge, get positive charge here. Therefore, here this positive pole is called positive. 1, 2 poles will observed here. This is positive pole. This is negative pole. So this type of covalent bond is called polar covalent bond. So polar covalent bond and this molecule is called polar molecule. The property is called as polarity. So we are observing this different dissimilar atoms. Dissimilar atoms means they having different electronegativity. So in case of polar molecule, the property is called as polarity. The molecules which exhibit polarity, they also exhibit one property. That property is called as dipole moment. So what is dipole moment we will discuss in this class. So here I will explain dipole moment. So here you take any molecule here, HCl. So it has a high electronegativity, it has low electronegativity. Therefore it gains positive charge, it gains negative charge. Therefore, now we will discuss about dipole moment. So dipole moment mu equal to charge on pole into distance between two poles. So charge is intimated by Q and distance is D. So simply we are changing the product of charge and distance of polar molecule is called as dipole moment. So the product of charge on one pole and the distance between two poles is called dipole moment. So it is denoted by m or mu. So units are dipole units. Dipole is intimated by D, capital D. So one dipole equal to, so here charge means coulomb or ESU, electrostatic units. Distance means centimeters and meters. Therefore, units are charge units into distance units. So that is the units of dipole. Therefore, dipole moment is equal to the product of the charge on one pole and distance between two poles is called as dipole moment. So dipole moment is intimated by m, small m or mu. So whatever it may be, in some books they are intimated as m, in some books they are intimated as mu. So after that, so units are dipole units. One dipole equal to one dipole equal to 3.33564 into 10 power minus 13 coulomb meters. Coulomb for cube, m for distance. This is one. After that, 10 power minus 18 ESU centimeters. 10 power minus 18 ESU centimeters. So this is our CGS and MKS. So SI system this is and CGS system this is. In SI unit this one and CGS units this one. So this is one dipole. So actually, so dipole moment is a vector quantity. So actually it is a vector quantity. So it is intimated by arrow mark, positive end to negative end, like this. So vector quantity. So it is a vector quantity and intimated by arrow mark, crossed arrow mark, crossed at one end. So positive end to negative end, like this we are intimated. So this is about introduction of dipole moment. So after that, so here we have one more discussion is the vector sum of the bond dipoles of various bonds. So for example, multiple bonds are there. So it is the vector sum of the bonds, multiple bonds. For example, here, this bond. A is there, C, D, E, like this. So this is vector sum. In this direction, in this direction, in this direction. In this direction it is mu1, it is mu2, here mu3. The total mu equal to mu1 plus mu2 plus mu3. So if in this direction minus mu4, like that. So vector sum of the various bonds. Vector quantity means in physics you know that one vector quantity means like this. In spatial arrangement also we are considered. So this is about dipole moment. So I will take calculation of resultant bond moment. Next one is calculation of resultant bond moment. Calculation of resultant bond moment. So here A, C. So here in this direction this is mu1, in this direction mu2, this is theta. So mu r is equal to under root of mu1 square plus mu2 square plus 2 mu1 mu2 into 2 cos theta. So this is the formula. So 2 mu1 mu2 cos theta. So this is the formula. 2 mu1 mu2 cos theta. Theta equal to bond angle. Theta equal to bond angle. So this is the mu1 square plus mu2 square plus, so a square plus b square plus 2ab cos theta, like that formula. So in this direction we are considered, in this direction we are considered. So therefore mu r is calculated by mu1 square plus mu2 square plus 2 mu1 mu2 into cos theta. Theta here bond angle. Here theta equal to bond angle. Bond angle. By this we can calculate resultant bond moment. Resultant bond moment we are calculated by using this formula. So this is about vector quantity. That's why we are considered in this direction. In this direction. So this is about calculation of resultant bond moment. Calculation of resultant bond moment. Now we discuss about type of molecule. Type of molecule and example. Dipole moment is possible or geometry. I will take few examples. I will take and I will explain here. I will take molecule. Type of molecule. Type of molecule. AB type. So for AB type, I will take example HF, HCl, HBr, HI, H2. So what is the shape of these all molecules are linear. This is also 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 linear. HH, hydrogen. So here it has less electronegativity than this one. Therefore it gets positive charge, it gets negative charge. So it is positive charge, negative charge. Here also positive charge, negative charge, positive charge, negative charge, positive charge, and here also negative charge. No, here only there is no charge at all. In case of hydrogen, so hydrogen are same atoms, therefore linear molecule, linear molecule. Therefore there is no polarity. Therefore these molecules are exhibit polarity. Polarity is observed here. There is observed polarity. So there is no polarity in this because these molecules are. Therefore these are having mu is not equal to 0. In case of this mu value is there or 0.10 or something, 1.78 or 1.07, 0.70 something. So they having value. So 1.70 something like this, they have a value. Therefore, mu is not equal to 0 here, mu is not equal to 0 here, mu is not equal to 0, mu is not equal to 0 here. But here mu equal to 0 because there is no polarity. If there is no polarity, there is no dipole moment. But here there is some value. Not equal to 0 means there is a value. That means here there is a value, there is a value, there is a value, there is a value. But in case of linear molecule, there is no value. So this is about type of molecule. We are taking so many examples. We are discussing so many examples of dipole moment.